So I put a set of steps off to the side for scatter plotting data. Choose your explanatory and your response variable. Your explanatory goes on the horizontal, your response on the vertical axis. Remember that your explanatory explains your response. It's inputs on what we used to call the x-axis and outputs on what we call the y-axis, but we're going to give them new names now, not just x and y. So in this case, the percent of the population who did not receive dental care is explained, we think, by the year. The year is the explanatory, and the response is the percent. The year determines what that percent is going to be. Some years were higher and some were lower. So the year determined or was the independent variable, and the percent was the dependent variable. It depended on the year. So now that I've decided what is my y and what is my x, what is my explanatory, what's my response, I'm going to carefully define those, okay? And I'm going to let my year be, let's see, t for time. I'm going to have that be the number of years after 1999. That's going to be my explanatory. My response is going to be percent, so I'll call that P, okay? And that's going to be the percent that did not receive needed dental care services due to cost. Okay, so that's going to be my percent, not with no dental care. Due to cost, actually, is why they don't have dental care. So I should put all that. Now, once I decide what my variables are and define them, I'm going to label my axes. So you can see in my scatter plot here, I have labels of X and Y, and that's not what I want. I want T and I want P, okay? And my percent is as a whole number here, and my T looks like it's years since 1999. As long as I have that defined off to the side, I don't have to put anything more as labels. All right, and I've already plotted my points carefully. This is 1999 right here at year 0, and there's 2000 right there at year 1, okay? 1 year after 1999. What they tell me to do is to next, after I've made my scatter plot, I have that now, I'm going to write the equation of a line of best fit. It's not going to be the line of best fit. We're going to have better ones, okay? But how they want us to do this line is to pick 2 points in in the data set to write the line. So if I was going to do that, I probably wouldn't like to pick these 2 points because that would give me this line, just a horizontal line. I probably don't want to pick these 2 points because that would give me this line, and that doesn't really best fit the data. If I want to best fit the data, I want to pick points that are far apart and kind of representative of the way the data looks. So I think I'll pick one at the end, beginning, and one at the end. Those are the 2 I'm going to pick. So that is the 2001, and I'm going to pick the 2008 one. Maybe you pick different ones. So what I'm going to do to write the equation of that line is write 2 ordered pairs, explanatory, comma, response. 2000, remember, is not 2000, it's 1, comma, 8.1. And 2008 then would be 2, 3, 4, 5, 6, 7, 8, 9. 9 years since 1999. That was 12.6. Now, if I want to write the equation of my line in best fit, I need slope first. Slope, you might remember quickly, is rise over run, or the change in y, delta means change over the change in x, or maybe you remember it as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, I don't have x and y, I have t and p, but I can kind of pretend like these are x's and y's. So I'm going to subtract my y's first, 12.6 minus 8.1. And I'm going to subtract my x's next, 9 minus 1. Order doesn't really matter. You just have to make sure that you keep the order the same in the numerator and the denominator. So in the top, I got 4.5. And on the bottom, I got 8. If I take 4.5 and divide by 8, I get 0.5625. 0.5625. And I'm going to leave that as a decimal rather than a fraction. You're used to doing that with slopes, but I'm going to leave it as a decimal because what we're doing here is a line of best fit. And in that case, we want to stick with our calculator through everything we do. So we're going to stick with decimals. So remember how you wrote your line equation of a line? I like to write point slope form, which means that I set up my slope right here. And like this, I like writing my line of best fit that way. And then I input in here just one ordered pair, x comma y. And I could choose x equal 1 and y equal 8.1 to do it. You probably don't do it that way. Most of my students, the way they do it is write y equals mx plus b and solve for the b with an ordered pair. The only thing is we don't have x and y. What we have is t and p. So keep that in mind. We know our slope. Our slope is 0.5625. And if we take a matching set of t and p, we could put t equal 1 here plus b, and we could put p here, 8.1. So I'm just going to use my nice arithmetic to solve that. I just do 8.1 and subtract that 0.5625, and I get 7.5375. So the equation of my line is P equals 0.5625 T plus 7.5375. And if I sketch that line, it should give me that line right there. That line should have the slope of up 0.5625 and over 1. And it should have a y-intercept of about 7.5375. And that's what I'm going to call my line of best fit. Now, the next thing I want to do is interpret that slope. And this is very important. Interpreting slope is very important. And I said in the class kick the words that you should say. For each additional, and then you want to give your explanatory variable, which was time. Now, I'm not going to put time. I'm going to say for each additional year, we predict, and that should always say we predict, okay? Because you don't know for sure. You don't have the best line of fit. And even if you did, some of these points are quite far off, right? So for each additional year, we predict and now I want to give my explanatory variable, and that is the percent without dental care due to cost. And now I want to make a decision. Is that increasing that percent or decreasing? And I can clearly see that from both my data and my line, the cost increases. And how much does it increase? That's my slope. My slope is my coefficient on my t. So it increases 0.5625. And then I got to put units on that. What is increasing? It's the percent that's increasing. So 0.5625%. All right. When I choose the units that go there, it's going to be the units on my response. That's interpreting my slope. My y-intercept is 7.5375. Okay. And to interpret my y-intercept, or I might call it the vertical intercept because it's not a y-axis, right? So interpret my vertical intercept. That's when the year is 0, but I'm not going to say year is 0. Okay, so I'm going to say in 1999, we predicted that the percent of percent without dental care due to cost is 7.5375%. But that's funny because we actually know what the percent was in 1999. It was 7.9. So now you can see why our line is just an estimate, a prediction. It's not definitely going to get you what the values are. It just gives you a good guess at what the values are. It shows you the trends of the data. That's your line of best fit. Okay, next we want to try to construct a residual plot. Now you can notice how the residual plot has a totally different looking window. It's just positives, outputs, and negative outputs, because our residuals are our actual minus our predicted, right? So what we want to do here is take our actual data points, and underneath the actual data points, what I'm going to put is the result of taking those data points and inputting them into the line of best fit equation. So I'm going to take my 1999, which was year 0. I'm just going to redo all these 1, 2, 3, okay, so that we have good inputs. And I'm going to take 0 and type that into my function in place of t, into my line in place of t, and see what I get for my predicted percent. I already know that this one was 7.5375. Now I am supposed to subtract these in order, the actual minus the predicted. So I have to type 7.9 minus 0.75375. I get a residual here. I'll put my residual in green. My residual here would be 0.3675. So I'm going to plot that down on my plot at year 0. So this is still time. At year 0, my residual is 0.3625. That's what this should say, 0.3625. 3625. So I'm going to plot at year 0, 0.3625. So when I look at my, on my axis here, when I plot it, it's going to be in positive land, 0.3625. Now I don't know how far off these are at maximum. Like this one looks like it could be looks like it could be like 1 off, a whole 1 off, right? Almost a whole unit or more than 1 unit off. So when I do my scaling, my 0.3675, I might want to go like 0.25, 0.5, 1, 0.75, 1, 0.2, 0.75, wait, 0.75, 1, and 1.25, like that for my scaling. So that 0.3625 would be like here-ish. And there's my first residual. I'm going to do one more residual, and then I want you to finish the rest of them, okay? So to do the next one, I want to fill in that blue bubble with what I get when I put 1 into my line for t. So when I put 1 into my line for t, it's 0.5625 times that by 1 plus 7.5375, and I get 8.1. So what I get for a predicted value is 8.1. If I subtract 8.1 from 8.1, I get 0. So the next point that I plot at t equal 1, if I call that t equal 1, is right on the axes. No residual. Positive residuals are possible. 0 residuals if you got a perfect. And then negatives are also possible. So you finish the rest of this table. In the next one, fill in that blue bubble with what you get from the line equation when you put 2 in place of t, and then subtract these 2 numbers and plot that right here. And on the slide, on the next slide, I'll show you my ending results.